All right, let's dive into something pretty wild. We're going to explore what might just be the next giant leap for AI. We're talking about agents that can teach themselves, adapt, and literally evolve all on their own. Let's get right into it.
So, just to frame this whole conversation, start with this question in your head. What if an AI could learn from its mistakes, not just once when it's being trained, but continuously, forever, for its entire life? This isn't just about getting a little bit better. It's a total shift in what AI is and what it could become.
To really get why this is such a massive deal, we first have to talk about the AI we use every day. For as powerful as these systems are, they've got this one critical flaw. They're basically frozen in time.
Think about it, right? A big language model gets trained on a ton of data, and then it's shipped. From that second on, its core structure is locked. If the world changes, if there's new information, or if it runs into a totally new kind of problem, it can't fundamentally change itself to adapt. It needs us, the engineers, to go all the way back to the drawing board and start over.
This little comparison here just nails the difference. Today's AI, it's like it read a textbook one time and now has to take tests for the rest of its life based only on what was in that book. A self-evolving AI, though, is like a student who shows up to class every single day, constantly learning, constantly getting better from new experiences and mistakes. So the big question is, how do we build an AI that can learn for its entire lifetime? Well, researchers have come up with a new vision, and it even comes with a set of guiding principles to make sure this evolution is safe and actually productive.
Okay, so here's the core idea, the definition. We're talking about an autonomous system, something that acts on its own, that is built from the ground up to systematically improve itself. And it does this by interacting with the world around it, getting feedback, and using that to make itself better and better over time.
And to guide this incredibly powerful new ability, the researchers actually took a page from classic science fiction. But here's the really brilliant insight. Where Asimov's laws were about moral rules for how robots treat humans, these new laws are technical guardrails for how an AI treats itself. They're all about making sure its own evolution is stable and safe.
The first law, and it's the most important one, is to endure. No matter what changes the AI decides to make to itself, it can never compromise its own safety or its own stability. This is the foundation. First, do no harm to yourself.
Law number 2 is to excel. Basically, any evolution has to be a good thing. The agent can't evolve itself into being worse at its job. It has to at least maintain its current skills or, ideally, get better. So the key takeaway here is that evolution has to equal progress.
And then, finally, as long as it's following those first two laws, the third law is to evolve. This is what gives the agent the power to autonomously change and adapt. It's the engine for improvement, but it's kept in check by those really important guardrails of safety and performance.
Now, this whole idea of self-evolving agents, it didn't just appear out of thin air. It's really the next logical step in a journey that AI has been on for the last few years. So let's kind of trace that path.
This visual here does a great job of showing the whole story. We started with models that were trained once, and then, boom, frozen. Then we figured out how humans could tweak and fine-tune them after they were deployed. From there, we got teams of AIs that could work together. And all of that is what leads us to where we're headed now. Systems that can improve all by themselves.
Let's just quickly break these stages down. It all started with MOP, or offline pre-training. You train the model, you lock it. Done. The next step was MOA, which let us fine-tune them. Then we got MAO, which was a huge leap. Now you have teams of AI agents that can collaborate, and that brings us to the future. MACE, where those teams of agents learn directly from the world to improve themselves automatically. You see, each step hands over a little more autonomy to the AI.
So we've talked about the what and the why. Now let's get to the really fascinating part, the how. How does one of these agents actually evolve? Well, it all boils down to this really simple but incredibly powerful feedback loop.
It's like a 4-step dance. First, the agent tries to do something. Second, it gets feedback. Did it work? Did it fail? How well did it go? Third, this internal optimizer takes that feedback and makes a little change to the agent. And fourth, it just repeats the whole process, a little bit smarter every single time. It's trial and error, but happening at lightning speed. So when we say an agent optimizes itself, what's actually changing under the hood? Let's look at the specific building blocks that can be evolved. So the evolution can happen on a bunch of different levels. An agent could literally rewrite its own prompts to be better. It could reorganize its own memory to be more efficient. It can learn how to use new tools, change the way it works with other agents, or even tweak its own core reasoning engine.
Take prompts, for example. An agent might start with an instruction that's just, okay. After trying a task a few times and failing, the optimizer could realize, hey, if I just rephrase this one part, I get much better results. And poof, it rewrites its own prompt for the next go-around.
Or think about memory. This is pretty wild. An agent might learn that for a certain kind of problem, it's way better to store memories as a web of connected ideas instead of just a simple list. So it could autonomously restructure its own memory system to boost its recall. It's basically upgrading its own brain.
So what does this all add up to? Well, we are standing right at the dawn of what you could call lifelong AI. We're talking about a future where our AI systems aren't just tools we build, but more like partners that co-evolve right alongside us.
And the implications here are just staggering. I mean, imagine a team of AI agents in a science lab, just designing and running experiments 24/7 to discover new medicines. Or an AI that lives inside a huge software project, constantly finding bugs, writing the fixes, and updating the code all by itself.
The researchers put this shift just perfectly. They said, we're moving from AI as a static executor to AI as a continually learning, co-evolving participant in whatever system it's a part of. It's no longer just a tool. It's part of the team.
And all of this leaves us with a final, really profound question. If AI isn't just a static thing we create anymore, but a constantly evolving entity, what does that make us? Our job might shift from being a builder to being more like a guide, or maybe even a gardener, cultivating this evolution. What that new partnership looks like, well, that's a question we're all going to have to answer together. Thanks for joining me on this one.